જે લોકોના જાન સુધી નીકળી જાય આ છે પ્લાઝ્મોડિયમ ફેલ્સીફેરમ. તો એવા મોસ્કીટો જેના અંદર પ્લાઝ્મોડિયમ ફેલ્સીફેરમના
A very good morning to one and all. We have our expert for today's special outreach program on World Malaria Day, Dr. Sharad Dalai sir. Sir, on behalf of entire team GUJCOST, I take this opportunity to welcome you to this special outreach program. And sir, we have 4 regional science centers at Patan, Bhuj, Bhavnagar and Rajkot, and 30 community science centers across 30 districts of Gujarat. So all of them have joined, and they have the student and teacher participants also at their specific venue. So with this note, before starting the formal program, I would like to introduce, I will read out some brief bio of Sharad Dalai sir. Sharad Dalai sir is the presently director, Institute of Sciences at Nirma University. He is a trained of research experience in infectious disease, and he has so many honors in his name, and he has guided several PhD students. He has received funding from various Government of India and Gujarat government authorities. So sir has very strong research base, and with this note, without taking much of the time, we would be starting our this session. And sir, we have our project director sirs also with us today. Dr. Girish Goswami sir from Bhavnagar. We have Dr. Narottam Sahu sir also. Sir has also joined. Sir, I would request you to give a welcome address.
Okay.
Sahu sir.
Okay. Very good morning. First of all, I thank you for.
Good morning.
Good morning.
Good morning. Thank you so much for which you are going on. Thank you so much, and we are looking forward to listening from you. Thanks, sir.
Thank you. So I will try my best to I'm not truly a public speaker, but then on this occasion I thought I must do whatever is possible, at least to encourage our younger minds and who really understand malaria is a problem and something must be done about it. Let me share my presentation. I'm finding it difficult to share. Is it any specific instruction? Normally I should go to window and share. So
WhatsApp. Sir, can you please share it to me so I can share it from this?
Yeah. Maybe that will be the best now.
Yes.
So, okay.
इसको कहीं रेंज करिए yes. आप नीचे से ट्राई करो। हाँ ज्वाइन करो मीटिंग ज्वाइन करो गूगल लिंक शेयर किया था ना कल जल्दी जल्दी
Yeah, I have already shared.
मेल में आया डाउनलोड हाँ पक्का मेल में
अच्छा VA AVIT. Yes.
Yeah.
Share it, sir.
Share serving program on
Share कर दे उसको.
No, sir.
This is no, I just want to know whether you are able to see this entire on the full screen.
Full screen ना देख रहे हो window share.
Okay. So, most of you are familiar with fever. Then at the last stage it come out of the hepatocyte fever. Then at the last stage it come out of the hepatocytes and infect RBC. And that is the time when we feel all the symptoms. We think that yes, we have malaria. In fact, liver stage is mostly asymptomatic. RBC stage, we get all this inflammation, fever, chills, all the symptoms because it infects RBC, propagates, induces a lot of inflammation. And when mosquito, if you consider even now also malaria cases is very close to 3 million, and then cases are also quite high in India. Please go to the next slides. And deaths, although death rate has gone down, but it is still in the alarming number. A lot of issues with respect to drug resistance to chloroquine and many other forms of also derivative of chloroquine had come, but then at present moment we have attenuation. Another good measure. In fact, they are not getting mosquito bites as much that getting. This is also in a way helping, and this has helped in reducing this, transmission of infected mosquito. It has spread all over the world, and this this is now the intensity of the drug resistance that you notice. So this is why we need to have vaccine if you really want to contain malaria. But to that matter, any diseases that affects at a large scale must requires effective vaccines. And malaria it definitely attracts a lot of attention for that reason. Next slide. So this is what I have been telling, that you of course need drugs to immediately take care of infection, but then drug resistance challenge because you are now generating new parasite, so they can infect a lot more vigorously. This is where you have to have vaccine. Then let us review what are the vaccines now in place, and then we'll talk about the problem associated with these vaccines. Next, please. So for a moment, let us see what is vaccine and what it really contains that we are injecting. Let's say recently we all have taken COVID. It will contain basically the material from the pathogen. Sometimes we can use the whole parasite or whole virus, like Bharat Biotech had made Covaxin for us, or we take an antigen like tetanus toxoid you are taking, TT vaccine, which is an antigen, protein antigen, toxoid, which is basically modified form of the toxin. And sometimes you take polysaccharide, like in case of hide the same infection when you encounter down the road. And then, of course, adjuvant you require, particularly for subunit vaccines, adjuvant which will potentiate your immune response. Next slide, please. Is we can develop immune response. If we can develop immune response to natural infection, then coming down with infection. So these are the evidence tell us that yes, we can make vaccines. Naturally, we do develop immune response. Now that needs to be boosted to the extent that we should be able to protect ourselves. But there are many challenges, unlike viruses or some of the parasite, but definitely malaria is a lot more challenging. If you look at even COVID virus or SARS-CoV, there are not many antigens. Even HIV, which is immunogenic in nature, which can really trigger immune response. So that is a challenge. So it's multi-stage, but doesn't mean we cannot have for the malaria vaccine case. Those are the questions. Another thing which we have been so this is what is called transmission blocking vaccine, although it has not gone to clinic yet, but it is quite promising. Next slide, please. So this is basically various vaccines that have been made or tried at various stages of clinical trial. And what RTSs initially, which was made by Glasgow, um, and few other vaccines now, like old sporozoid vaccines, which is now being tried in Mexico particularly. And once it is a clinical trial is successful, it may be tried in various other countries. Next slide, please. So if you look at these vaccines from the beginning of making this vaccine to all the way to trial, takes a very long time. This is what some of the pre-erythrocytic malaria vaccine, when you say pre-erythrocytic, before the blood stage, RTS is also considered pre-erythrocytic because before it gets into the liver stage, I call it pre-liver stage, before parasite getting into the liver. But then what we are using, that this is irradiated sporozoid, and RTS is basically, but irradiated sporozoid is mainly would work in the liver stage. So you can say it is a liver stage vaccine. Next slide, please. Erythrocytic, vaccines, although many trials have been made, we so far we do not have any novel vaccines, which seems to be doing, very good job. Next slide, please. But vaccine efforts as such also, if you look at, very time consuming, research also demanding. And transmission blocking vaccines, although it started a long ago, but then most of the work has been done in last 15-20 years. Hopefully it will come to the clinic very soon. Next slide, please. So now whole idea is that if we succeed, even partially, at various stages, targeting mosquito So that is the issue before us. Next slide, please. So this is how these, RTSS vaccines work. It basically, it's made as a virus-like particle. It induces strong immune response, certain T cell response, but not the type of T cell response that we thought. We thought maybe it is going to generate CD8 response. Barely it generates CD4 response, but it induces good antibody response, but may not be so strong that it can capture all these sporozoids as they are entering into the liver. Next slide, please. So now a new form of RTSS vaccine has come called R21. In fact, it is also made by the same institute, Oxford Jenner, which also made Covishield for us. If you look at initial RTSS, so it has very fewer numbers of CS proteins, but now they have modified it in such a way that it has more CS protein. So that means its ability to induce antibody response at least would be enhanced. And they seem to be claiming that it can go up to, let's say if it was 30 to 50% efficacy, now they are claiming it might go up to 80% efficacy. Okay, so, and we are thinking probably this R21 vaccines, will be much better in taking care of the infection, particularly in the children in Africa and sub-Saharan countries, and maybe in the South Asia. Next slide, please. So this is basically summarizing, what are different stages where, targeting the infection at the sporozoid stage and at the liver stage, in the blood stage, although not very successful. There is some limited success story. Next slide, please. You may skip the next slide also. Please go to the next slide. Yeah, this is basically what is talking about various antigens from the sporozoid, which is basically which enter who are working in vaccines. I'm just giving here some names, not necessarily these are the only people working. But let's say ICGB, which is actively working on making vaccines. MSP protein they're using, AMA also protein using, Professor Chauhan's lab, and our collaborator in University of Hyderabad, even in NII also, they are making attenuated parasite. Now they are genetically attenuating the parasite, which may not establish full-blown infection but induce immune response, and which have been shown to generate strong liver stage immunity. And my lab, of course, we do not make a vaccine per se, but then we are working on these vaccines to improve the efficacy. So we are understanding immune response, what type of immune response it is generating, why these efforts, the vaccines, not so successful. Is it because the vaccines are not inducing durable immune response? That is what my lab is working on. Next slide, please. What is the approach now they have? Next slide, please. So I am going to show you some of the work that is done on sterile protection. Clinical protection means we may be having parasite in our body at a low level, but we do not get any symptoms. That is called clinical protection. But sterile protection means you have no symptoms, no parasite in the body. So, and in fact, this was the vaccine which was shown to induce sterile protection. So I took interest in this because nominal the malaria vaccine actually induced sterile protection. I thought we can do certain immunological work in this. And in fact, it induced both humoral response as well as cellular response. Next, please. Although it induces antibody response, CD4 and CD8 response are critical. And it has been shown if you deplete the mice, the host in which, let's say, you have immunized, we are using rodent parasite, then mice come down with, infection, even if you have antibody. So therefore, and these are required to eliminate the infected hepatocytes. Just like virus, unless you eliminate the infected cells, you will continue to have virus progression. The same thing also here. Unless you take care of, eliminate completely the infected hepatocytes, then merozoites will come out from the hepatocytes and infect the RBC, and that is how you again spread the malaria. So CD8 was critical in this. Next slide, please. So, but then, unlike other vaccines, COVID vaccines we took only, 2 times. 3 times we gave to people, elderly people, because we thought maybe they can come down, they may be having weaker immune response. But these vaccines you have to give multiple times. So in mice you give 3 times, 4 times irradiated sporozoid. In human case you give 5 to 6 times. This is where I have my own reservation that how come it will be possible to vaccinate so many people by giving so many doses, no? But maybe at the moment it can be experimental vaccines. We learn that it induces sterile protection, and we learn immunology out of it, maybe T cell response, B cell response. Maybe we can find out antigens against which B cell response can be generated, T cell response can be generated. We can find protective antigens. Maybe we can use them in future to make subunit vaccines, but then we should learn what is the type of immune response is generated, how we can improve the immune response in a way that it can remain, effective for a longer time in our body. So as you can see here in this experiment we have done, it requires at least 3 doses to induce sterile protection, 100% protection. If you give only 2, maybe 60 to 80% mice are surviving. Next slide, please. But then what we know that, next slide please. So as we teach in our immunology class, whether you are naturally infected, generating immune response, or you are getting vaccine, then these lymphocytes get activated first. Sometimes you must have noticed when you have some infection on the upper part of your body, then you have lymph nodes are swollen. This is basically sign of this expansion of these lymphocytes. Antigen specific T cells and B cells actually expanded, and they'll be engaged in taking care of infection. Even if they are not, most of them also will be die because of massive inflammation, and it's a process called activation induced cell death, AICD. And a pure number of cells which will be numberably much higher than naive T cells that you have started with. And when they survive, those cells we call memory cells. And those are the memory cells as if they remember the first time insult or infection. And they will remember after 2 years it will come, but already we have these T cells and B cells ready to fight. And those are called memory lymphocytes, B cells. When we encounter that infection called challenge, and they get reactivated and they fight the infection. You have to maintain those memory cells, antigen experienced cells, longer in our body to maintain the efficacy. What we have shown, and I'll show you, next slide please, that in the this vaccine which is inducing sterile protection, that protection doesn't last very long, no? So then we are trying to ask these questions when they are induced, and if they are induced, whether they persist in the body for a longer time. Next slide please. So these are basically, we are trying to look at the cells, based on these markers, and the effector molecule in this case we are using CD107, which is the marker for cytotoxicity, and also interferon gamma. These are the effector molecules required to help the T cells to eliminate the infection. When you say CD107 in the sign of granzyme and porphyrin release, so the cells are releasing that, they are going to act on the infected cells and eliminate. And interferon gamma also indirectly help to eliminate, we'll discuss that later. But the T cells which are making those effector molecules are used as here as the immune correlate of this protection. Next slide please. And what we need, we're trying to find out, do we need so many immunization? Is there any reason behind it? Can you go next? Yeah, put the question. Yes. So if you look at the cells, they are not only CD8, but they are also cytotoxic based on the markers, at least CD107 activated cells for which KLRG have been used, and they are using now interferon gamma and IL-2. As you can see in the last panel, so we generate good number of cells, little over 1,000 cells present in the liver. That is what is the requirement to kill the infected hepatocytes. That means you need a particular number, threshold of the T cells to be protective in nature, and that is achieved only when, in this case, you are giving 3 immunization, 4 immunization. In human case, it requires 5 to 6 immunization. So you need that many immunization you need. That is why you keep taking the booster dose. Most of the vaccines, 2 doses, maybe 3 doses, but malaria vaccine, it seems to be working if you give 5 to 6 doses in human. Next slide please. And this is what, of course, we have published saying that yes, but then the cells, do they persist in your body longer? Next slides please. So you can skip this. So yes, the answer is yes, they could persist, but then persistence of the cells, whether it is really providing the protection. Next please. And this is where we try to find out, after immunizing mice with 3 doses of irradiated sporozoite, then we will try to find out how long they are maintaining the protection. So at different time point in this experiment, we have gone up to a year or so. We are challenging the mice just to find out. Let's say we have taken COVID vaccines, whether you are protected or not. If we encounter an infection, if you do not come down when you encounter challenge, that is called challenge. If you do not come down with any symptoms, then we say, oh, we are protected. So the same experiment we are doing, we immunize first, and experimentally we are challenging and trying to find out whether mice are protected or not. And this is what the experiment we have done. And we go to next slide, please. So as you can see, up to 210 days, we are generating good T cell response. We are able to reactivate those cells, and that also get reflected in terms of the protection. If you go beyond 270 days, after 7 months or so, mice are losing protection. So that means you are maintaining 100% protection up to 6 to 7 months. No, after that you are losing protection. So when you give vaccine to people, they are not even able to maintain even one season, malaria season, let's say this year to another next year, then it is no more a good vaccine. So it is a good vaccine, promising vaccine, because it is inducing T cell response, antibody response, protection, no clinical symptoms, but we are able to maintain this protection long enough, at least not even for a year. So this is where the problem comes, how to make it a better vaccine, how to make it more effective. It's a promising vaccine, but how to make it effective. So this is why this, basic research is very important. Next slide, please. But then we are thinking, what we have learned as people are encountering infection in the endemic area. And it has been shown, and most of us who are living in the endemic area from malaria, initial years we may be getting, but once we develop protection, and particularly adults, as long as they continue to live in the endemic area, they don't come down with infection. But once we come out of the endemic area, let's say we go to United States or Europe, where there is hardly any malaria, we come back after 2 years, and then we go to the same endemic area where we were living before, then we get down with infection, come down with infection. So this is what is the idea we are talking. So as long as you are getting mosquito bite, that means infected mosquito bite, not any mosquito bite, you are able to maintain. This is what I was telling you, with all this vector control, with anti-malarial drug, malaria parasite burden has gone down. It has not become zero. But then this mosquito, this infected mosquito, this transmission has gone down. And even if we take a vaccine like horse parasite vaccine, there is no guarantee that we can maintain that. Time to time, this exposure is required. But we cannot think that, oh, we'll continue to have this infected mosquito. This is why we have to have alternative strategy to think of making, vaccines whose efficacy will be durable. Next slide, please. So, and many people even do not think that we do develop, liver stage response. They think we can only develop immune response against the blood stage. But this review, this thought-provoking review we wrote actually in Frontier several years ago, which suggests that we may be having liver stage immunity, and that could be because of our food habits. Some other day we can discuss this. Next slide, please. So it requires basically children which are protected. Most of the time you'll find children, they require at least 3 times exposure before they develop immunity. And then once they develop that immunity, even if it is clinical immunity, to maintain that, they need exposure. Next slide, please. So this is what I was just giving an example. Let's say we are in endemic area, let's say Ahmedabad or some part of Gujarat, let's say Beirut or southern part of Gujarat, where there is malaria, and now you have left for USA. Most of us go there, and after a couple of years you come back, you come down with infection. You fail to maintain that. But what is required to maintain? Next slide, please. Next slide. So this is where what we did. So after giving irradiated sporozoite, before those mice lose protection, we are giving one infectious sporozoite challenge. And now we are trying to study, and we saw that when you give one infectious sporozoite challenge, the mice which are surviving 6 months, 7 months, surviving is they are maintaining the protection. Now their protection is maintained.
दिमाग को आपको बताना कि इसको भाई तुमको याद रखना है, उसको रिपीट करते रहना पड़ेगा, और रिपीट करने के लिए भी चैप्टर बहुत लंबा है।
Next slide, please. Somebody is talking. Can you mute?
उसको कर दिया को पता, फिर आफ्टर 21 days यू रैंडमली टेक योर सेल्फ टेस्ट।
So if you compare,
38th डे पे देखो आपको क्या वो याद
just
रहेगा।
go back to that slide. Yeah. Challenge, just like we are natural living challenge, they are able to maintain the T cells much better. So this is what is the model we have been using to address what is really happening to those T cells and how we can improve those T cell response. Next, please. We have also looked at the B cell response next, but then we don't find that antibody response is compromised that much. Next, please. Yeah, go ahead, please. Go to the next slide. So this is basically showing that if you give infectious sporozoid challenge following irradiated sporozoid, which is attenuated, you can maintain CD8 T cell response longer. Next question you are asking, how that is happening when you are giving irradiated. Next one, please. Next. When you are giving irradiated sporozoid challenge, irradiated sporozoid, keep putting the cursor. Yeah, just here. Then irradiated sporozoid, they are not developing fully. But when you give infectious sporozoid, now they are developing, but they are not, establishing infection. Maybe new antigens are expressing. That probably is generating more and more T cells against other antigens, and that seems to be helping. That is one thought we have, which we are pursuing. Next, please. Another idea. This is where GUJCOST actually supported us, and subsequently DST also supported us to pursue this idea. If you recall, yeah, please stay. If you recall what we are saying here, yeah, we are saying here when you are giving irradiated sporozoid, it is inducing sterile protein. I'm just giving irradiated sporozoid, that is also considered as a threat to your immune system. That is how you are responding. And when you are giving infectious sporozoid challenge, that is also a threat, we are also responding. But then how do you perceive this threat? This is what I'm giving an example of horse. Let's say you think horse as a danger, but then one horse is walking, another horse is running. What would be your response to a running horse versus walking horse? An infectious sporozoid challenge is a running horse here. So normally one would go away from the running horse because you want to, escape that danger. But our immune system does opposite. Whenever we see some pathogen which are highly pathogenic, let's say take example of commensals in our gut versus pathogenic bacteria, we try to induce inflammation, eliminate them. And this is what is actually done. Instead of running away from horse, we run towards the horse to eliminate them. In this case, the pathogen. So this nature of this is what is called innate immune response, which is critical, and that helps in triggering adaptive immune response like T cell response or B cell response and modulate that response. And we are trying to understand, and if we can understand it, we can make a better adjuvant to make those T cells or B cell longer lived to fight the infection. This is where the concept we have been pursuing. Next slide, please. So you can go further, and this will basically, please keep going. This is going to be reflected in better T cell response, and some of those T cells will be differentiated and maybe longer lived, and ultimately giving us the protection. Next, please. And we have done some work and published in Frontiers of Immunology. Some other time detail we can discuss, but this has given us a hope that if we give infectious sporozoid challenge, we can maintain these T cells longer. That means we should now, understand the immune response, the mechanism operating behind. Next, please. So please keep going. Please keep going. Okay. And this is why we are asking many questions here. The T cells that we have generated in absence of infectious sporozoid challenge versus sporozoid challenge, what is the change brought into the T cells? We are asking questions. If we do not infectious sporozoite challenge, do they fail to survive? Are they dying? Or even if they survive, they fail to get reactivated. Let's say we have taken COVID vaccines, we are generating T cells. When you are encountering new infections, if you do not wake up them, then it is same as not having those cells. Another issue also, when you wake up those cells, which happens in the draining lymph node, not at the site of infection like liver, if they do not migrate to the liver to fight the infection, then it is also as good as not having those T cells. These are the questions we are asking. So I don't want to show you the detailed experiment, but I would suggest that if you can keep going to few of these slides down, it will be helpful. Please go down. Do not have that, then you come down with infection. Please go down. If you can go to the slide number 76, that will be better. If you can quickly go to the slide number 76. Slide number. If you can keep going through your cursor, so that will be helpful. This will take a lot of time to explain. So. Yes. So what we have done after doing all those experiment, which is a bit complex and it requires time for me to explain. What we have shown that when you give infectious sporozoite challenge following irradiated sporozoite, just like we take vaccines and we get challenged naturally, that helps improve the survival potential of this memory T cell, and that is critical. And if you do not, and also we have found that if you do not give infectious sporozoite challenge, just irradiated sporozoite challenge, those memory T cells, whichever T cells are maintained in a smaller number, they takes much longer time. Like in case of malaria, it takes in rodent malaria, in mice it takes about 48 to 72 hours for the for the cycle to develop. In human case, it takes about 7 to 10 days. That means as the parasite is entering to the liver, if the T cells are not reactivated, they cannot fight infection. So you have T cells, but they are not reactivated in timely manner, then they will come to the blood, then cause malaria. So you may be thinking that you have T cells, they can fight, but by the time they actually come to the battlefield, it's already late. So this is what is happening. So therefore, timely reactivation of memory T cells is key to ensuring sterile, protection. This is what we have shown, and that is being ensured by infectious sporozoite challenge. Next. Then you cannot give infectious sporozoite challenge to people. No, we are getting naturally, that is a different issue. This is why we are doing experiment. So what type of innate immune response they are generating? Can we find some modulator, immunomodulator in the process, which might be helping maintain the cells much longer? And now we are doing refined experiment for which now ICMR, has supported us. We are starting to do this experiment, and our approach here is that we learn the complex science behind it, come up with a simpler solution. Maybe solution exists, which is being utilized for maybe other, vaccines, maybe virus vaccines. Can we use some synthetic ligands, we call TLR ligands, pathogen associated molecular pattern, now synthetic form of that, which can engage their receptors, which induces, inflammatory mediators, immunomodulators, that will act on those T cells and help maintain. So this is what is now we are doing. So we are very hopeful that with this information, we will be able to help, make those vaccines which are promising but not generating durable immune response. Now we can maintain their immune response so that, in a short run, it can go to the field maybe in another 5 to 10 years. So with this, I would like to end my presentation and thank you. If you have any question, I'll be happy to answer. Thank you.
Sir, wait for 2 minutes, sir. Just 2 minutes. चालू करो वीडियो
ऑन कर
संगीत पे आप ऑडियो करो मैं वीडियो करती हूँ
कर दिया थैंक यू वेरी मच सर am I audible?
Yes.
Yeah. So thanks a lot for sparing your valuable time from your busy challenges in development of malaria vaccine, and you have presented in most simplified manner. So on behalf of entire team GUJCOST, I would like to thank you for your time and taking this session and guiding all of us on this World Malaria Day. So thank you once again, sir. Thank you.
Thank you. If there are any questions, that is fine. I can take. No,
yes, I'll ask all other. I'm requesting all the regional science center project directors, sirs, and our CSE coordinators. If there is any query or questions, this forum is now open for question and answer session.
Dr. Sarath, this is Dr. Girish Goswami, Director RSC Bhavnagar here.
Yes.
So
very nice.
it's really wonderful to have a good talk on this Malaria Day. I just wanted to tell you one thing. We are a regional center, और हमारा जो maximum जो crowd है, they are from rural background. So एक simple words में either in Hindi or in Gujarati, as on this day as an expert of this domain, आप क्या कहना चाहते हैं बच्चों को, कॉमन पर्सन को, ताकि मलेरिया का जब तक वैक्सीन मार्केट में आए, बिकॉज इंडिया में 1977 से वी आर हैविंग द मलेरिया इंस्टीट्यूट एंड रिसर्च इज गोइंग ऑन टिल डेट वी आर वर्किंग, बट इन जनरल एज ऑफ नाउ लुकिंग टू ऑल द कंडीशंस, उसको हम सिंपल हम क्या एक मैसेज कन्वे कर सकते हैं ताकि उनके टेक होम मैसेज रहे, आज मलेरिया डे पे मैं गया और मुझे ये मलेरिया के बारे में मुझे ये कुछ पैटर्न या कुछ मेरा प्रिकॉशनरी मेजर्स मुझे लेना चाहिए ताकि बिना मेडिसिन के मैं मलेरिया से कैसे दूर रह सकता हूँ.
यस, सो एक बार मलेरिया हो गया तो मेडिसिन लेना पड़ेगा, नो दैट वी कैन नॉट अवॉइड, बट द मेन थिंग दैट हाउ simpler measures we can take, and which basically I would say vector control, if you can do on your own. Okay.
Sir, sorry to interrupt you. मुझे क्षमा कीजिए सर, मैं अभी गोस्वामी साहब ने भी कहा, एक्चुअली हमारे ऑडियंस जो है वो रूरल बैकग्राउंड से ज्यादा होते हैं, अगर आप हिंदी या गुजराती लैंग्वेज में समझाए तो बहुत अच्छा रहेगा.
मैं अंग्रेजी में हिंदी में बोलने सॉरी गुजराती में बोल नहीं सकता, हिंदी में भी बोल रहा हूँ.
हाँ हिंदी में बोलिए सर।
अगर एक बार मलेरिया हो गया, इसके लिए मेडिसिन तो लेना पड़ेगा, दवाई लेना पड़ेगा, एंड आर्टेमिनेसिन इज दी नाउ। अभी आर्टेमिनेसिन डॉक्टर के पास जाके लेना पड़ेगा। मगर कहना क्या है, हम कैसे इसको मस्क्यूटो कंट्रोल करना होगा, ओके। एंड इसलिए ऑफकोर्स मस्क्यूटो नेट तो हमको यूज करना है, मगर जहां पे हम रहते हैं, जैसे डंप यार्ड होगा जहां पे पानी जम जाता है, बारिश के टाइम आता है, इवन इमीडिएट बारिश के बाद भी, पर्टिकुलरली जब ठंडा आता है, पानी भी जम के रहता है, उस टाइम में मलेरिया ज्यादा फैलता है, ओके। गर्मी के टाइम में इतना नहीं होगा। गर्मी के टाइम में अगर पानी है तो थोड़ा सा जैसे 30 डिग्री उस टाइप का टेम्परेचर में मस्किटो ग्रो करेगा। और जब ठंडा बढ़ जाता है उस टाइम में इन्फेक्शन होता है, बिकॉज वो मस्किटो को इन्फेक्ट कर सकते हैं जब आपको काटता है। तो इसलिए आपको जहां पे भी डंप यार्ड है इसको देखना पड़ेगा, इसको कैसे ड्राई करके रखना पड़ेगा। वो हमारा घर के आसपास जितने हैं सब कम्युनिटी एरिया में जितने कुछ है, अगर इतना हम कर सकते हैं, एंड मस्किटो नेट यूज करना पड़ेगा, बिकॉज मस्किटो नेट किसी को अच्छा नहीं लगता है, गर्मी लगता है, सुनने कंफर्टेबल नहीं लगता है, मगर इसको यूज करना जरूरी है। जहां पे भी ज्यादा मस्किटो है इसको यूज करना पड़ता है। इवन अहमदाबाद में भी इतना मस्किटो का प्रॉब्लम नहीं है, फिर भी हमको मस्किटो नेट यूज करना पड़ता है। अगर इतना कर सकते, एंड अगर मलेरिया होता है तो सिम्टम से पता चलता है, नियर बाय हॉस्पिटल जाके थोड़ा माइक्रोस्कोपी करके, बिकॉज जहां पे भी हम पैथोलॉजी क्लिनिक जाते हैं वहां पे नॉर्मल ब्लड स्टेज के साथ, नॉर्मल ब्लड काउंट के साथ हम मलेरिया पैरासाइट काउंट भी करते हैं। इतना अगर हो पाता है, दवाई ले लेते हैं, मस्किटो कंट्रोल करने के लिए जितना भी मेजर हो सकता है, हाइजीन मेंटेन करना है, इतना करेंगे तो बहुत सारे प्रॉब्लम दूर हो जाएगा, ओके। सो एंड हमेशा हाइड्रेट को कैसे अवॉइड करके, अगर मस्किटो ब्रीडिंग कम कर सकते हैं, इवन डेंगू भी कम हो जाएगा।
Is there any other queries from our centers or RSCs, CSCs?
सर
यस,
अगर सिंपल लैंग्वेज में बहुत साधारण लोगों को अगर हमको समझाना हो कि जो मलेरिया का वैक्सीन का निर्माण है वो अभी तक क्यों नहीं हुआ, उसके 2-3 मुख्य कारण क्या है, तो हम क्या समझा सकते हैं 2-3 मुख्य कारण जिसके वजह से मलेरिया वैक्सीन अभी तक नहीं निर्मित हुआ है?
एक कारण है जो मैं पहले से बताया है, हमको एग्जैक्टली पता नहीं है कौन सा एंटीजन सही है। सही मीन्स ऐसा नहीं है सिर्फ इम्यून रेस्पॉन्स जनरेट करता है, बट जो इम्यून रेस्पॉन्स, इसको
अगर हमको नॉर्मल कॉमन लोगों को समझाने के लिए, जो एकदम सामान्य लोग हैं जो साइंस बैकग्राउंड से भी नहीं है, उनको अगर हमको समझाना हो तो हम कैसे समझा सकते हैं?
ओके। सो जो हमारा जो बॉडी में जो प्रतिरोधक शक्ति जो जगाना है, इसके लिए जो मटेरियल चाहिए तो हमको मलेरिया पैरासाइट से मिलता है। हमको इसके बारे में और ज्यादा जान करना जरूरी है। हमको कुछ पता है, बहुत सारे जो मटेरियल को लेके हम वो जो प्रतिरोधक शक्ति बढ़ा सकते, ये सब हमको पता नहीं। जितना भी पता है इसको लेके कैसे वो हमारा जो प्रतिरोधक शक्ति बहुत दिन तक बॉडी में रह सकता है, उसके बारे में भी नॉलेज पूरा पता नहीं है, ओके। और जो पूरा पैरासाइट को लेके हम सोचते हैं तो वैक्सीन हम कर सकते हैं, उसका भी टेक्निकल लिमिटेशन है। मिलिट्री को देने के लिए, छोटा ग्रुप को देने के लिए हो सकता है, बट इतने लोगों को देने के लिए जो टेक्निकल एडवांसमेंट होना चाहिए इतना नहीं हुआ है।
आते आगे जाएगी
वो सब एग्जाम्पल जैसे 3 एग्जाम्पल में दिया हूँ, तो ये हमारा बॉटल नेक अभी भी है, अभी भी ये हमारा पास चैलेंज है, यू नो। सो इसलिए
Thank you,
बहुत
sir.
सारे
Thank you.
काम करना, रिसर्च हो रहा है। सो शायद अनदर 2-3 साल में कई सारे चीज हमको आंसर मिल जाएगा इसमें।
Thank you very much, sir. Thank you.
Okay.
So if there is no further queries, then we are concluding this session. Is there any, this is the last call. Is there any question from CSC side or RSC centers, all 4 centers and all 30 CSCs? Screenshot lena. I request all of you to turn on your video for a while so that we can take a screenshot. Any print screen वालों बताइए तो नहीं, एकदम easy है. I request all the project directors, all the CSC
Council wants to ask something.
સર માહિતી તો બહુ સરસ હતી, પણ એનું ગુજરાતી જોઈએ, કારણ કે બાળકો સુધી પહોંચાડવા માટે પ્લેટફોર્મ ગુજરાતી જોઈએ છે.
Can somebody explain me if I have to answer? Yeah.
Sir, he's saying that we need to convey it into Gujarati. So yeah,
I can understand. But
yes, Panchal sir, now our duty is to simplify this and convey to the students.
Okay.
આપણે સમજ્યા એ બધી વસ્તુઓ એને એકદમ
સિમ્પ્લિફાઈ અભી ગુજરાત ठीक ठाक सीखना पड़ेगा.
हाँ, આપણે સ્ટુડન્ટ ને સમજાવીશું.
तो भी अच्छा रहता, बच्चों को हम एक्सटेंड कर सकते नहीं.
जी जी,
पूरा माध्यम तो हमारा गुजरात का ही है.
So okay, sorry, I have not picked up Gujarati yet, so
no issue, sir, no issue. I think that is our part now, all the CSC coordinators, that we have to first of all understand what are the challenges in malaria vaccine development, and then we have to convey the same in most simplified and lucid manner to all the students. આપણે જ આપણા સ્ટુડન્ટ્સ ને સમજીને એને કન્વે કરવું પડશે. છોડી દો બેન, વાંધો નહીં. આ બંધ કરો ને સ્ક્રીન, એટલે મને પેલું દેખાય. So with this note, we are once again thankful to Dr. Sarath Dalai sir for sparing his valuable time. I am also thankful to all the project directors, sirs, Goswami sir, Sastri sir, Sumit Vyas sir, Rajendra Patel sir, and all our CSC coordinators who have joined and